Hi, this is Masha, and let's do the example set 3 together. So, for the first question, they say that the cooling medium is chilled by the sodium chloride brine. So, let's start it off with what they give us. Medium brine and what? We know that the rate of flow is 1.8 and the water is in temperature 8 minus 8 and leaves at 10. And exchange your 155 meters square. Find the overall heat transfer coefficient. 3.38 and 4.8. Okay, so let's write down. So the T1 is 32 degrees Celsius, and we don't know T2. And this one, the water is 1.05, and CP is 4.8, and then 55 meter square for the second one. T1 is 10. Sorry. And T2 is minus 8. And the NaCl is 1.8, and CP is 3.38. So the formula is CP NaCl equals to CP plus T2 of water, and then we can substitute, which is CP of the second one here, 3.38 times 1.8 times 10 minus temperature is 4.18, 0.05 over 2, and T2 is 7 degrees Celsius. Let's change the color. Delta T is equal to T1 minus T is 32 minus 10, which is 22 degrees Celsius. Delta T2 is T2 minus T is 7 minus 8, 15. And delta T is delta T minus T2 over log delta T1 over delta T2, which gives 22 minus 15 over log E delta T1 over delta T2, which is log E 22 over 15 18.28. Success. Q. We need to find the overall heat transfer coefficient. So Q equals to U A delta Tm. This is the formula. T1 minus T2. U 4.18 1/05 2.7 minus 7, sorry. And U is to 0.109 degrees Celsius, or it is 109 joules. Is the answer? This one. Okay. For the second question, we need to estimate the steam requirement. Heat 50 kilograms of pea soup, and the soup is 18 degrees Celsius, 100 kPa, and the pan has heating surface of 1 overall is 300. Okay, so the formula that I'm using is PAES equal P much plus PATM, and then I have this, which is 201.3 kPa, and from appendix B, it's 120, 125, this is the T2, and 198.53 and 232.1. So we do the between this is going to be 201.3 kPa. And then we refine. This one is easy. 153 over 2 minus 198.53 equals to T minus 120 over 125 minus 120 equals T2 equals to 120.4 degrees Celsius. So this one. Then overall heat. Okay, so Q is equal to U T, which is 300 times 1 times 120.4 minus 18 degrees Celsius is joules per second, or 30.72 joules per second. And then Q 30.72 equals M times 272. Therefore, is 0.014 kilograms per second. Another weight is 50.22 kilograms per hour. Moving on to the third one. A food containing 80% of water, dry and moisture content of 10%, and the initial temperature of the food is 21. Calculate the quantity of heat energy required, and the latent heat representation of water at 100 then atmospheric pressure is 2,257 The specific heat of food is 3.8, and the water is defined, and also the energy requirement. Water removed. First of all, we write what we know. So from the basis, food is 1 is 21 degree. Water 80% is solid, 0.8 kilogram, and solid is 0.2 kilogram. And after that, final T2 is 100 degree. Water 10% again is X kilogram, and solid 90% is 0.2 kilograms. So to find the water, how many kilos water, so we do water over solid is 10 over 90. Then X is 0.022 kilogram. So we can know that water is 0.22. Okay. Then we know that the water is removed. Fine, collect water required. Okay, then we do here. We need to find how much is 0.8 minus 0.022 is 0.778 kilogram. And Q food substitute 1 times 3.8. Yeah, 3.8. 100 minus 21 plus 0.778 times 2. The atmospheric pressure is 2,257 gives 2,056 kJ over kg of food. For the fourth question, if the mass transfer coefficient of a free water surface moving 0.015 kilometer, the rate of movement is 1, and the temperature of 28 or 40 and pH of 40%. So first thing first, 40% RH is this here, and we need to look here, 40% is here, so I make it a line up here, should be here, and then make a line to see the moisture content. And this will be our YA. Let me erase this 40%. Okay. And as we know that over here 28 degree into S stream, so 25, 26, 27, 28, and also 30%, so 28 is here, and 40%. drop right here. Oh, the line is not straight. This is the line here. Let me move it. That should be here and here. Okay. And then I'll make a line to there. 0.024 is YS. And then we find the rate of evaporation is K YS minus YA. Okay. YS is 0.015 kilometers times 1 meter squared times 0.0242 minus 0.016. It's here. And then it's equal to 8.4 times 10 minus 5 kilograms per second. Whew. And then the fifth question. A drum dryer is being used to dry starch. Initial moisture content is 75% on wet basis and the temperature is 1 degree. Drying food is heat transfer. Assume the thickness of food drum is 0.3 and the thermal conductivity is 0.55. If the drum is rotating 2 rev per minute and the food occupies 3/4 of the circumference, we need to estimate the moisture content of film being scraped off. So the drum dryer is like this. And it's 2 rev per minute. Occupy is 3/4. And this one is 1 meter, and this one is so food or drum 3/4 times 2 inch. Equals 2 pi times 1 times 1 times 4 times 0.2 times 10 to the minus 3 equals 0.07 times 10 to the minus 4 minus 0, which is the volume of food on drum. Okay, then P food, P water, so it's 10 times 3 times 7 power 3 times 7 or 7 times 10 to the minus 4 is 0.71 kilogram. And then we need to categorize that water and solid, right? Water is 0.71 times 0.75, which is 0.53 kilogram. And for solid, it's 0.71 times 0.25, equals 0.18 kilogram. And after that, we do one over. Then substituting, it's equals to 100 times 10 to the minus 3 over 0.55, which is 1.8 minus 3. Therefore, choose and then Q, U, A, L, T, so 557 times pi times 1 times 1 times 3/4 times 138 times 100 gives 4.99 times 10 power 4 joules per second. And therefore, N is equal to 4.99 times 10 to the negative power 4 joules per second over 2057 times 1000 over 1 equal 0.22 second, and the residence time will be, let's see, time is 3 over 4 times 30, which is 22.5 seconds. Okay, thank you very much.